Thanks. So I'm going to take a step back and just talk about broad overview of the oil and gas system. For those of you that know oil and gas well, a lot of this is going to be redundant. Then we'll get to some new stuff later on in the presentation. We'll have plenty of time for Q&A, so start thinking of your questions now. I like hard balls. We'll take off the microphone, and any questions you want to ask, I'm happy to answer. All right, so I'm going to start off talking about the oil and gas system from several aspects: production, processing, and distribution. These are really fundamental elements. I'm going to speed through them at light speed, so any additional information you might want about these topics, feel free to come up and talk to me about afterwards, or send me an email and I can give you additional resources. Okay, starting from the beginning, where does oil and gas come from? Oil and gas are essentially ancient fossils, hence the name fossil fuel. They've been subject to certain characteristics of time, heat, and pressure. Imagine an ocean, shown here, 300 or 400 million years ago. Over time, the plants and animals in that ocean or large inland sea die. They fall to the bottom of the ocean. They decay. Over time, new layers of sediment and rock are piled on top of them. As the hundreds of millions of years go by, the fossils are subject to heat and pressure. Essentially, we can think of them as being cooked over a really long period of time. As they are cooked to different degrees and different time frames, they form different types of oil and gas molecules. Oil and gas is a spectrum, right? There is no one gas, there is no one oil. It's a spectrum of different molecules that create all the different types of oil and gases that we hear about and that we use. This is a very quick description of conventional, so-called conventional oil and gas development. This is the type of oil and gas development that's been going on for something like 150, 175 years in the United States. The layer of rock where the organic material is cooked in the first place is called the source rock. In this case, that's indicated by the black layer, the shale, which we'll talk more about in a minute. But shale is the source rock for most oil and gas. Over thousands of years, or millions of years, some of the oil and gas in that source rock migrates towards the surface and becomes trapped by an impermeable layer of rock called a cap rock or a seal. Those oil and gas traps could be filled with mostly gas, mostly oil. All right, there's mostly gas over there. Here's a mix of oil and gas on the right side of the figure, or it could be mostly oil. Again, there's a spectrum of different types of molecules that might be trapped under those cap rocks. These types of formations are the ones that oil and gas companies have gone after for decades. This is so-called conventional development. You tap it with a single vertical well going down, or multiple vertical wells going down. The natural pressure in the formation sends the oil and gas up to the surface. You collect it and send it on the way. More recently, advances in technology have allowed oil and gas developers to go directly after the source rock, the shale. That's where horizontal drilling and hydraulic fracturing comes in. If you see my really nifty little animation there, you see the horizontal and directional drilling. Miracles of technology at work. All right, so we'll talk more about horizontal drilling and hydraulic fracturing right now. So people have known that oil and gas is in the source rock for many years. That's common knowledge. What has changed is that technology has advanced to the extent that it's now economical to produce oil and gas from these formations, where it was not before. So the two major techniques that have made this possible are horizontal drilling and hydraulic fracturing, or fracking, two things that I imagine you've all heard about. Horizontal drilling is when a well is drilled vertically and then turned at an angle, sometimes called the kickoff point. The well then runs parallel to the target formation, which is often shale. Sometimes it's some other type of rock, but usually it's going to be shale, especially in the United States. Once the well has been drilled, hydraulic fracturing takes place, usually in multiple stages. This involves pumping at very high pressure, millions of gallons of water, sometimes a little less, down the wellbore with some additional sand and chemicals to make the production happen. Right? So you send that stuff down there, you pump it in at very high pressure, the water travels into the wellbore and fractures the rock. Some of the sand that you pump down there stays behind to help leave those cracks open to allow oil and gas to flow into the wellbore and up to the surface. Okay, here's another type of unconventional oil and gas production that you've all probably heard about. Oil sands, found in Canada, as well as in large quantities in Venezuela, which you don't hear about so much. So oil sands are found largely in these two places of the world. There are also some in the United States and elsewhere around the world, but Canada is really the place where most of it's being developed these days. Oil sands closest to the surface are typically strip mined, right? As you'll see here. You see a lot of pictures of these on the news. Heavy machinery basically strip mines out the oil. It's processed and separated so that the sand and rock comes separate from the oil. You transport the oil to market. But the largest deposits of oil sands in Canada are actually found deeper underground. They're too deep to mine. So they are accessed with multiple different types of recovery processes. But the one that I'll show you here is called steam-assisted gravity drainage. The way that this works is you have some oil sands, maybe 30 meters or more below ground. You pump in steam at very, again, high pressure, high temperature. That helps allow the oil and gas trapped in the rock, trapped in the oil sands to flow more easily. Once the oil becomes heated up enough and liquid enough, then it begins to flow back to the surface. So there are two wells going down, one pumping down steam, the other pumping out oil. This is actually how most of the oil sands will be recovered as they are recovered over the next few decades. Okay. The next step in the oil and gas system is refining and transportation. So after crude is produced, it's transported by a pipeline, by rail, by truck, all sorts of different ways, to a refinery where it goes through a variety of processes to produce the fuels that we're familiar with today. As you can see, the primary product of crude oil is typically gasoline, as well as diesel and jet fuel, along with a few other products. This varies by the type of crude oil, right? Different types of crude oil tend to produce more heavy chemicals. Some lighter types of crude oil are well suited to make gasoline and not so well suited to make other things. So again, there's a spectrum of oils and gases, and they produce different products. The petroleum transportation system is really, really big in the United States, right? People talk a lot about the Keystone Pipeline and other pipelines. There's a whole lot of pipelines around the country. This figure shows crude pipelines, which are the filled-in lines, petroleum product pipelines like gasoline or diesel, which are dotted lines, and refineries, which are those little boxes with oil barrels on them. Refineries are concentrated along the Gulf Coast as well as around some other population centers in the country. All right, natural gas processing and transportation is pretty similar to oil, but it's a little simpler. There's a couple steps that you kind of take out. Raw natural gas is transported from the well to a processing facility where one component of natural gas, which is primarily methane, that's the stuff that is mostly used to generate electricity, used in your home for your stove, is separated from other natural gas molecules like propane or butane, right? Butane you'll find in a lighter, propane you'll find in a gas grill that might be in your backyard. Those products are separated out at a processing plant, transported separately and sold separately. But they're all different types of natural gas. So the lighter component of natural gas, which is methane, is transported again through pipelines around the United States. This figure is a really cool one because it shows the scale and direction of natural gas flow around the country, right? So you can see that most of the natural gas is processed and flows from the Gulf Coast up towards the Northeast, as well as towards Chicago. This is changing a little bit, right? This figure I think is 3 years old or something. There's a whole lot of new production in the Northeast now, in Pennsylvania, West Virginia, and that's changing some of the flows that you would see in this figure. Okay, speeding along to oil and gas prices. Values added along each step of the supply chain for both oil and gas. For petroleum products like gasoline or diesel, typically the largest component of cost is the crude oil. Other major contributors are refining costs, distribution costs, marketing costs, and taxes, everybody's favorite part. So you can see in 2005, the price of gasoline was relatively low because the price of crude oil was relatively low. In 2012, crude oil prices were high, gasoline prices were high. Today, crude oil prices are low, gasoline prices are relatively low. So other factors do affect oil and gas prices, but the crude oil, let me step back. Other factors do affect gasoline prices and diesel prices, but crude oil is the predominant factor. For natural gas, the cost of the fuel is actually substantially less than for most petroleum-based products. This is from a utility in the southwest of Vista Utilities. You can see that the wholesale gas cost, the cost of the fuel, is actually only about about 4/10 of the total price that a consumer will pay. The larger costs are fixed transportation costs like pipelines, as well as equipment and people at the utilities that manage the processing, the distribution, and the marketing of the gas. Okay, a quick look here at who are some of the different players in these spaces, right? Those of you that are thinking about careers in the energy industry, if you're interested in the oil and gas sector, these are the different types of firms you might be looking at. In the upstream realm, these are the companies that explore for and produce oil and gas. Companies like Anadarko, Apache, Chesapeake, Continental, and that's only through the seas. There are many exploration and production companies, some small, some really big. There are oil field service firms like Halliburton and Schlumberger. These firms provide specialized expertise or equipment to the independent petroleum producers to help them increase production, make things run more smoothly. These are the companies that often do the hydraulic fracturing work for the exploration and production companies. The midstream sector is largely processing and distribution. So Kinder Morgan, Enbridge, these are pipeline companies mostly. They also do processing. There are crude by rail companies like BNSF. They ship a lot of crude oil, especially from North Dakota to other parts of the country. Downstream, we have refining and marketing. So refiners like Valero, Marathon, Sunoco, Tesoro, right? You also might see their names on gas stations around. They don't produce the oil, they don't transport the oil, but they refine it, they bring it to a gas station, and they sell it to people. For natural gas, the firms are usually not as well known because there aren't street corners that have natural gas companies with giant price signs on every street corner. But the processing is done usually by independent midstream firms, and then it's delivered by utilities like Piedmont Natural Gas here in North Carolina and other utilities around the country. And then there are integrated international oil and gas companies, or IOCs. These are the big oil and gas companies. When people talk about big oil, this is usually what they mean. ExxonMobil, Chevron, Shell, BP, they do a little bit of everything. Okay, so I'm gonna stop blabbering for a second and have a little quiz. This is a chart showing, some of the biggest oil companies in the world by proved reserves, right? How much oil and gas do they control? So I'm gonna see if anyone has a guess who some of those really big ones are. The ones that control more than 300 billion barrels of oil equivalent in oil and gas reserves. Any guess who one of those two companies might be? Just shout it out. Exxon, Shell, I heard Exxon, Shell. Okay, gotta keep going. BP, good guesses. Okay, so this gets really interesting when you see that the independent international oil companies are really small compared to the national oil companies that are run and managed by governments around the world, right? So NIOC, National Iranian Oil Company, I think that stands for, Saudi Aramco in Saudi Arabia, PDVSA in Venezuela, as well as some other national oil companies. So these firms operate sometimes under different rules than international oil companies. International oil companies are typically driven by profit, right? They're trying to make money. And the national oil companies are also driven by profit, but they may have other goals in mind, right? They may have political objectives that they're seeking to advance with their oil and gas production. All right. Oil and natural gas pricing. I'm not going to go into too much detail here. This is a figure that shows a variety of changes in the global oil price over time, and a lot of different events that have happened at those different times that show changes in oil prices relative to major world events. The point of this slide is not to talk about each one of these events. The point of this slide is to tell you that events anywhere in the world that affect oil and gas production in one part of the world affect global oil prices, right? Everyone pretty much pays the same price for oil around the world. It varies from place to place depending on the oil. But generally speaking, disruption in one part of the world affects prices for everyone. And that makes a big difference. With natural gas, prices vary more widely from place to place. In Japan, over the last several years, natural gas prices have been extremely high because Japan did what? Anybody? That's right, shut down its fleet of nuclear reactors, which meant they needed a whole lot of natural gas to create electricity in the country, which meant they had to import a whole lot of natural gas through liquefied natural gas tankers, through pipelines. Japan does not have a lot of its own natural gas or any kind of natural resources. So its natural gas prices spiked. In the United States, on the other hand, natural gas prices dipped over about the same period. And that's largely because of hydraulic fracturing, horizontal drilling, led to a substantial increase in natural gas production, which led to lower prices. Now, the reason that natural gas prices are priced regionally rather than globally, like oil is because natural gas, there's really only one way to transport it, or one major way right now, and that's through pipelines, right? Pipelines can't easily move around the world. If Japan needs gas right now, you can't build a pipeline right now to it. It's going to take 10 years, it's going to take 20 years, which means that price responses to natural gas in certain regions are going to be more volatile than they might be if it was a truly integrated market. So there is this thing called liquefied natural gas, where natural gas can be supercooled and shipped on tankers around the world. Japan imports a lot of LNG, liquefied natural gas, but that's also expensive. It costs a lot of money to do all that shipping and all that liquefaction, as it's called. Okay, I'll just spend a couple minutes on the shale revolution, which is kind of been the focus of my research over the last couple years. The shale revolution, a lot of people describe this as the biggest energy event in the last 25 years, basically since the Iranian Revolution. And I would tend to agree with them. It's really a big deal. So many of you probably know this story. Domestic natural gas in the United States. This is a figure of US natural gas production. It was pretty flat, right? Declining a little bit. Consumption was growing more rapidly, so prices were going up, right? In the United States, we were importing natural gas from Canada. We were building import terminals to import this liquefied natural gas. That was going to be really expensive. And then lo and behold, right, this new thing called shale and other tight rock formations came along, and production in the US has grown substantially. What that did in the United States is it took the projected prices that we were expecting in, say, 2008, right? 2008, the US Energy Information Administration, which is if you don't know about the EIA, go to US EIA or EIA.gov. That's your place for data. Live there for all your energy data. In 2008, the EIA projected that we were going to have relatively high natural gas prices for the foreseeable future, and a few years later, something else, right? So that 2014 projection may not look a whole lot lower than the 2008 projection, but if you think about all of the natural gas that's consumed in the United States, that difference between 2008 and 2014 is hundreds of billions of dollars a year. The same technologies that were applied to shale gas have been applied to shale oil. As many of you know, in the US, oil production has been declining since the 1980s. Again, there's a lot of angst about importing foreign oil in the United States, but the same technologies used for shale gas extraction basically created the same story for oil. Most of this new oil production has come from three places: the Permian Basin in West Texas and eastern New Mexico, the Bakken and Three Forks Shale in western North Dakota, and the Eagle Ford in South Texas. If you ever go to South Texas and you say Eagle Ford, people will look at you funny. So say Eagle Ford, like it's one word. All right, so as many of you know, shale gas, shale oil development, it's been happening in some places, some parts of the country where there hasn't been a lot of oil and gas development in a while. That means a lot of development is taking place closer to population centers than it maybe had before. And this, along with a variety of other factors, this is a really complex issue, so I don't want to simplify it, but a whole bunch of things have led to very acrimonious debate, right, about oil and gas development in the United States. And that's a debate that you've seen play out on cable TV or on the blogs if you follow the energy blogs. Here's a really quick, and I mean really quick, description of just a couple of research projects that I've been involved in here at Duke. One is a paper that I wrote with my colleague Richard Newell, who's the director of the Energy Initiative. We looked at all of this new shale gas production in the US and we asked, what does this all mean for climate change, right? How is it going to impact greenhouse gas emissions in the United States? I'm going to ignore some of these bullet points and just say that it's a complex issue. And I'll look at the fourth bullet point and tell you our sort of central finding, which is that the overall climate effects of all this new shale gas probably doesn't actually mean all that much for greenhouse gas emissions in the United States. Because of a complex set of factors, natural gas has been displacing coal for electricity generation. That reduces greenhouse gas emissions. But cheap natural gas means cheaper energy, which means people use more energy, which increases greenhouse gas emissions. There's also this issue of methane emissions from the oil and gas system, which are actually highly uncertain, but also increase the greenhouse gas footprint of natural gas. One of the things that you can say about cheap natural gas is that it has enabled certain policies, like the Clean Power Plan, which would have been really costly to implement before cheap natural gas. With cheap natural gas, it gets a lot easier to move away from coal, politically and economically. And this is not an explicit argument we make in the paper, but it's reasonable to think that cheap natural gas has made something like the Clean Power Plan a possibility. This is the last slide I will show you. This is, so I've been to all these places in the last couple of years. It's been really interesting. We've been doing a project looking at how oil and gas development affects local governments. This figure shows an extremely simplified version of the fiscal effects on local governments from oil and gas development. So the blue generally means that local governments in that part of the country have experienced fiscal benefits associated with oil and gas. Lots of new revenues, not too much new costs. The red areas show places where costs have outstripped revenues for local governments. So I won't go into detail on that. If you have questions, feel free to come ask me about them or check out our website. There is more information on our website about it. The project is called Shale Public Finance. And I think we have about 5 more minutes for questions.